This conference will now be recorded.
All right, this is the finishing last slide of the Law of Cosines 8.2 notes. The only thing we didn't get to, and this will help you finish up that last problem on the take-home quiz and the worksheet, is the how do you find an area of a triangle using some special formulas when you don't know the height or of the triangle. So like normally we would do 1/2 base times height to find the area of a triangle. So if we have a non-right triangle and we don't know the height, this is some approximations that we can use. One of them is the area of a triangle formula, and it says the area of the triangle equals 1/2 the product of the lengths of any two sides and the sine of the angle between them. So what that ends up being is there's three versions of this. So if your triangle is ABC for your, your angles and your sides, then this could be that the area is 1/2 AB sine of gamma, or it could be 1/2 AC sine of beta, or it could also be 1/2 BC sine of alpha. So it's always two sides and the angle in between them. So if you have that situation, that's what the formula you would use to approximate the area. If you don't, you could use, if you have all three sides, you can use what's called a Heron's formula. So Heron's formula says the area of a triangle with sides A, B, and C, whether it's right or triangle or not, is given by the formula square root of S times S minus A times S minus B times S minus C, where S is 1/2 of the perimeter of the triangle. So we're going to look at these two different examples. Now, sometimes you may not have side angle side or side 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 right away. So you can use the law of sines and law of cosines to get enough information to use one of the formulas. So sometimes you will have to find some of the missing pieces of the triangle to use one of these two formulas. So let's look at this one. So I have the triangle that is ABC, and I know that alpha is 60 degrees. Little b is 20, and little c is 30, so that's across from big C. And this is side angle side, so this fits perfectly into one of the formulas here. In fact, this one is 1/2 BC sine of alpha. So if we plug that in, that's 1/2 20 times 30 times sine of 60. So that's going to be, let's use our calculator. So sine of 60 times 20 times 30, and then divide that by 2. That's 259.8. If we needed to round up to the nearest whole, that'd be 260 units squared, because it is area. Okay, for this one we have all three sides, so we're going to use Heron's formula. We don't even really need to draw it. So you need to know the perimeter, so that is 50 plus 50 plus 25. So that's 125 for P. So S, remember, is half of that. So 125 divided by 2 is 62.5. So the area is the square root of the 62.5. And then you take 62.5 and you subtract each of these three sides. So 62.5 minus 50 is going to be a 12.5. Then we get another 12.5 because there's another 50. And then 62.5 minus 25 is 37.5. We multiply all of those together. And then we take a square root of this. So remember, I told you in class that you can take a square root by raising something to a 0.5 power, because that's the half power. So that is 605.15. If we round to the nearest whole number, that'd be 605. So 605 units squared. And what you round to is purely dependent on what the directions say. I'm just rounding to the nearest whole since there weren't specific directions given. So that gets us caught up, and that was the end of section 8.2.